2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there this afternoon or evening or whatever time you might be watching us, hopefully on YouTube there, all right? Yep, this show's popping up everywhere. We're glad if you've tuned in right now during the typical Mathline time. You know, we aren't doing call-in at this point, but what we do, we have specialized segments. I'm Ernie Roberts. I'm your host for this afternoon's specialized segments test prep version. Whew, that's a mouthful. And you know what? We're going to get started on it here. Got a little bit of help from our buddies and friends at Bearden High School. Some of the students there are helping us out on this, and they do a great job helping us a little, giving us some of the questions, feeding it. Sometime if your group would like to come into our studio and do some questions, we'd love to have them join us also. But let's see what's going on today. We are into some sort of function mode, I think. Absolute value and rational functions. Whew. Let's be absolute about being rational. How about it? Let's see what's going on with these problems. Like I said, it's kind of a test prep, so we're just going to be hitting a few items and ideas today and such. So let's take a look at our first problem we got set up ready to go. An absolute value, actually equation. Now, if it were a function, we would say y equals -2 times the absolute value, 3y, what is that, plus 6, all blah, 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 equals, well, we would just be figuring out what it is. We just say y equals that, and we would graph it. Now, the -12, we would have to figure out somewhere else to put it. But we would take just basically what's on the left-hand side and see what we could work with. Now, what we're going to do is figure out what y equals. Yeah. And notice I said what y equals? 2. 2 things we got to be on the lookout for. So let's see how we work. We start with the -2, which makes me nervous because so many times students say, well, if we run a negative through there, well, I really say don't do that because sometimes we forget to run signs in them. But what we're going to do, we're going to divide both sides by the -2 right off the bat. Because what the whole game plan, my friends, is to get the bars by themselves and what's inside the bars there. The 3y plus 6 is what's important. Now, notice what we did. We were multiplying by -2, right? So we're going to divide to undo that part. Pretty straightforward. But see what happens? Say goodbye to the -2's there. Already this looks nicer. We have the absolute value of 3y plus 6. And it's still bars. The bars have not gone away yet. They will in just a second. And what's good news out here is when we take -12 divided by -2, we get a positive 6. And that makes this problem very doable. Because remember, absolute value has to be a positive value here. When we start out with the -12, someone's going, oh, that doesn't look good, Ernie. That doesn't look good. But when we divide everything through by that -2, life is good. All right? We have a positive number for the bars to equal to. Remember, the whole idea of absolute value is how far away from 0. The distance a number is from 0. So we're looking at possibly this value giving us positive 6, which is obvious. But the not so obvious one is we also have to worry, well, what if this inside the bars gives us -6? Because you know the absolute value of a -6 is also 6. So let's test it out and see what we need to do. What we need to do is accommodate for two possibilities. First one is very straightforward. We're going to say 3y plus 6 equals 6. Straightforward, because that's what you see. And that's what my students always say, I got that part right. Well, it was pretty easy, yes. Now, let's go to the next piece, though. We also want to say that 3y plus 6 could equal -6. So, and notice I've removed the bars, all right? The bars are gone. There's a line down the middle. That's not a bar. The situation here is we're going to look for now 2 different values of y, in this case, for our variable. Let's see what happens. Let's subtract 6 both sides, because you know why? Because whatever you do to the left, you got to do to the right. Good old, in this case, subtraction property of equality. I'm getting 3y equal to 0. And again, some of you students are out there going, oh, let's panic. No, let's not. We're going to say 3 times what number gives us 0? Well, that's pretty obvious. Y equals 0. And dear friends, that's a solution. We'll check it here in just a second. Now, coming over to this one, we're going to say, same thing. We're going to subtract 6 from both sides. And my friends, this is a good old positive negative moment. These cancel, those do not, all right? Then we're going to have 3y on the left, and over here we have negative 12. You see that it's like negative 6 plus a negative 6, or negative 6 subtract 6, but it's not 0. And dividing time, we're going to get y equals negative 4. And I know we got some of you out there saying, I thought you said we couldn't have a negative number. No, we can't have a negative number with the bars equaling it, all right? In other words, we can't say 3y plus 6 in the absolute value bars equals negative 6. No, no, no. So we are allowed a solution that'll be negative. Let's see if it works, all right? First of all, the 0, if we put a 0 in there, let's go back and rewrite that. Got a little room down at the bottom for me, guys. Plus 6, will we get negative 12? Well, let's find out. Put a 0 in there. That's pretty easy. 0 plus 6. We're going to have a negative 12 equals negative 12. Life is good, all right? Let's test this other one out, because this was always the one people forget about. We've got 2 times the absolute value of, again, 3y plus 6, negative 2 equaling that negative 12 business. I just start with the same problem. And we're going to put the negative 4 in there this time. So we've got a negative 2 times absolute value of negative 12 plus 6. Do we get negative 12? That's the big question. Well, let's go back and figure this one out. What is negative 12 plus 6? It's going to give us a negative 6. Absolute value of 6, that's 6 again. Or excuse me, negative 6 is 6. It doesn't matter, right? As long as we have a 6 or a negative 6, we're going to get the absolute value to be equal to 6. So we've got 2 times our negative 6. No, we got our 2 times the absolute value of negative 6. And we still got a negative on that too, folks. Don't lose that. There we are. And this is going to go to 6. And we do get negative 12 equaling to negative 12 out of that. Once again, that absolute value of negative 6 goes positive and life is good. Yes, you could have skipped that little step in there. I want to make sure we don't forget that we have to keep the negative on the 2, because the negative times positive gets us back to that negative. So there's your start. And you know what? I said Bearden High School is going to help us a little bit today, so let's let them have a little moment here. Let's hear from one of those students, see what we've got going.
Got a math question? Mathline has answers. Hey, Mathline.
Hey Mathline, it's Hannah from Bearden High, Knoxville. I need to find the solution to the equation absolute value of 3x minus 4 divided by 7 equals 4. Can you help?
We certainly can. And by the way, folks, while we're working on these things, you're more than welcome to write these down at home and work along with me here, all right? At your dorm room or wherever you're working at right now. Let's see what is actually going on with this. We're going to find the solution, and it could be more than one answer to it. You know that. So we're going to solve the equation. And as Hannah said, thank you, Hannah, from Bearden High School there, 3x minus 4 divided by 7, and notice they're all inside the bars, equaling to 4 at the end. So get a chance, write it down at home. Some of you may say, oh, I'm used to seeing it looking like that. That's kind of how our textbooks like to write them. Let's see, we got 3x minus 4, put it in the bar. I'm going to rewrite it here so everybody else can do that at home. And the questions are the bars isolated? Well, they are, so we're ready to work. We're ready to work. You said, well, boy, that wasn't so bad. It really wasn't, was it? So let's see. We're going to take our 3x minus 4, put it over 7, and we're going to let that equal to 4, just what we see. Remember, what we see is what we get. Now, we've got to remember also that mess inside the bars can also equal negative 4. So let's put the mess down here again. It's not really a mess. It's a nice expression. Put it over 7. This time it's going to equal negative 4. All right? Got it? Everybody good? So positive 4 for this side, and then the negative 4. And once again, this is just our little divider. It is not absolute value bars here, okay? Just make sure we understand that. Quick thing first, when we have this situation, we need to get the 7 out of there. So we're going to multiply because it's in there by division. We're saying 3x minus 4 divided by 7. So we're going to clean it up and multiply the 7 through both sides. Put a 1 under there, or you can just cross multiply. You can make this like a fraction, cross multiply it. Ratio and proportion type going on here. And the 7 say goodbye. 4 times 7 don't say goodbye. It's going to give us 28. Over here we've got 3x minus 4. Now add 4. both sides. And we've got, looks like 3x equaling, wow, 32. And it doesn't quite come out even. That's okay, we can divide. We're on Mathline, and also you guys are taking ACTs and SATs and Algebra 2 end of course test, which is where you'll find something like this usually. And that's going to give us what, 10 2/3. Let me caution you. Some of you say, oh, isn't that 10.6? No, 3/5 is 10.6, all right, when you have 3/5. 2/3, remember, that's a repeating decimal. 6, 6, 6, 6, 6, it keeps going on and on. So go with the fraction. You can handle it. You all can handle it, all right? So there's our first start. Let's go to the second side over here. We're going to pick up 3x minus 4 again. We're going to do the same game. We're going to multiply both sides by 7. And that's going to give me a negative, what is it, 28? What your sign is going to stay negative. That's okay. We're going to add 4, both sides. And that's going to give us 3x equaling to, what, negative 24? It looks like what we're aiming for is x equaling negative 8, because then we'll subtract both. We're not subtract, I'm sorry, we're going to divide both sides. We're going to keep that negative sign, though, on the final answer. We're also going to check. Now, I went ahead and kind of jumped in here, but let's say 3 times 10 2/3. You're going like, whoa, what does that give us? Well, it should give you 32, right? And then 32 minus 4 gives us 28. 28 divided by 7. My goodness, it equals 4. That's good news. By the way, it was a positive 4. Absolute value is still 4, right? So what we want to see now is, if we put negative 8 in here, back up to our original equation, there we go, we're going to have negative 24 when it multiplies, right? Put a negative 8 in there, multiply, then subtract the 4. You got a negative 28 over 7. Well, that's negative 4, but remember, you're inside the bars. So what is the absolute value of negative 4? It gives you 4. So both of these are good answers. They check, and they're really not that hard to check back through, all right, when you get a problem that works and looks like this. Even 10 2/3, you guys can handle it. You're good, all right? Let's hear another Mathline question from our Bearden group.
Hey Mathline, I'm Daniel from Bearden High School. Could you show me that the functions f of x equals 3x minus 2 and g of x equals x plus 2 over 3 are inverse functions?
Very good. Thank you, Daniel, from Bearden High. By the way, we've got folks with us today doing some great question call-ins or film-ins, whatever you want to call them there. We are looking at two functions, f of x to be 3x minus 2, and our other little function, g of x, is equal to x plus 2. And notice that's a quantity. That's not just x plus 2/3 or something like that. It's x plus 2 all over 3. We're going to look to see if they're inverse functions. Now, simple rule, if they're inverse functions, then f of g of x, this goes back to your algebra 2, my friends, should come up and give us x. And if we choose to do f of g of f of x, I'll get it backwards there, that also should give us a result of simply x by itself in the end. That's your basic rule. That's your basic way to verify that two functions are actually inverses of each other. So let's play the game. Let's see what happens. So according to this, it says I'm going to start with the f function and I'm going to put g of x. So let's think about that a minute. That's like saying f of x plus 2 over 3 equals, and what are we going to do? We're going to put that value everywhere we saw an x. All right? So we've got a 3, looks like here. That's right. 3 times our little x plus 2. Put that all over 3. And what do we want to go from there? That's it, isn't it? That's all we got? That's all we got to do? Looks pretty easy, doesn't it? So let's see what that does. Well, it looks like we're going to have 3 times, oh, we got a minus 2, don't we? Don't forget that. That's part of the function. We got to put that minus 2 on there. This gets us started. By the way, what happens here? The 3's disappear. You're left with x plus 2 minus 2. Good news, because that's simply going to give us x, because these are going to just cancel out. So once again, you put in, and a lot of times students forget that. When you put that value in, remember, if there's some other information, you got to finish it off. Now, let's go back to the one up above. Let's do the g of f of x. So in other words, we're going to say g of, how about it, 3x minus 2 equals, let's go ahead and replace our x's there with what? 3x minus 2. And don't forget, plus 2 hangs around for the ride. Put it over 3. I am looking at, looks like 3x over 3. And you know what? The whole idea is supposed to equal x, right? And there we go. So that question is asking, are they inverse functions? In other words, do these hold true? Yes, they do. You always want to check both of them. Always check through both. Usually one works, the other is going to fly, all right? But I always like to show that both are doing it, and that's kind of our definition of it. So there you go, a quick review on inverse functions. Thank you, Daniel. And let's see what our next one is. What we got for another function question, I bet.
Hey Mathline, this is Samaya from Bearden High School in Knoxville, and I'm hoping you can help me on this. What are the excluded values for the expression 6 divided by x squared minus x minus 42?
Thank you, Samaya. And that's an interesting expression here. Looks like 6 divided by, and notice because they are parentheses, that means that whole trinomial, that x squared minus x minus 42, will be in the denominator. So when we're looking for the excluded values of x, we are looking for values that will force a 0 to happen in the denominator. The 6 really doesn't do anything for us at all. It's just kind of up there going along for the ride. We are worried about what happens when this denominator rides out to be 0. So what are we worrying about? Let's go for it. We're going to take x squared. We're going to say minus x minus 42. And my friends, we're going to let that ride up to equal 0 because that's what we're concerned about. And if you'll notice, we got a quadratic brewing here. I like quadratic. Everybody likes quadratics, right? If you know how to factor, they're so much fun. And this one is a factorable quadratic. You don't have to go to the quadratic formula or try to complete the square or anything like that. Let's just break it open and factor and see what happens. We're going to have parentheses. Make two binomials happen here, okay? Samaya, this is where we want to go. We've got x and we've got x. We have a positive and a negative. Why? Because I got a negative 42 on the end there. Which one wins out? Well, it looks to me like we're supposed to get a negative x coming out of this thing. So let's put minus 7 and 2 because you know that's how we multiply to get 42. That's what we're looking for. 7 times 6. And what do we get in the middle? We want a negative 1. So when we check real quick, and we will do that, aha, there you go. Now, thinking, hopefully you are. Hopefully we all are. Question is, what values of x will make, oh, don't stop there. It's not 6 and negative 7, everybody. We got to figure out what makes the 0 happen here. That's the whole point of breaking it apart. So what number plus 6? This is one you can do in your head. Subtract 6, of course, yeah. Negative 6 is what's going to happen there. Because a negative 6 plus 6 gives us 0. That's the whole idea. On this side, it looks like it's going to be 7 minus 7, so x is equal to 7. Now quickly, if we look back in here, quick check, mental check, as I keep saying, 7 times 7, 7 squared is 49. Subtract 7, we're down to 42. Subtract 42 more, you're at 0. That's bad news. That's an excluded value. So really what we're saying in this expression, we do not want x to equal 7. Lots of times you'll see that not equals. And let's see about our negative 6. Some of you go like, well, does that work too? It should. We have negative 6 squared, which by the way is positive 36. If you're trying to punt that in your calculator, it will punt out if you don't put a negative 6 with a parenthesis around it, and then square it. Then we're going to say minus a negative 6, which is like adding plus 6. So we've got 36 plus 6, subtract 42, and we have the problem. The problem being that we can't have a 0. So there's your other option. Those, Samaya, from Bearden High School, those are your excluded values for this function. By the way, you'd probably call those good old vertical asymptotes also if you were trying to graph that. And that might be something about our next question. You never know. And speaking of which, let's go to our fourth question from our Bearden folks here.
Hey Mathline, this is Parker from Bearden High School. I have a problem for you. What are the horizontal and vertical asymptotes of the function g of x is equal to 2x squared minus 8 divided by x squared minus x minus 6?
Parker, you read my mind that we were going to do one like this. How about that? You know, what's happening here is we have what looks like a rather nasty problem. We're looking for horizontal and vertical asymptotes of the function, as it says here, 2x squared minus 8 divided by x squared minus x minus 6. Now, I mentioned a minute ago that our restrictions were the vertical asymptotes, all right, of the function. Where are the restrictions happening? They're happening out of our lovely denominator down here. So that's the first thing we're going to be worried about. So let's off to the side here. I'm going to put a little off to the side here because we're going to look at some things. We're going to say this x squared minus x minus 6, we're looking for the values where bad news happens. In other words, at 0, what's going to happen. So what we do and what we see is we will factor. We'll get x minus 3 and x plus 2. My friends, it's awful easy to think that could be a 1 and a 6, or you could put the thing in the wrong place. Notice I got a minus 1 back in the middle. Good time to practice that factoring with you guys out there. And our solutions, remember how we did a minute ago? X equals 3, x equals negative 2 will give us 0. Remember, this is bad news bears. These are our possible vertical asymptotes. You say, Ernie, what do you mean possible vertical asymptotes? Hang on to that thought, all right? But right now, they're in the running. They're in the running. Now, as for the horizontal asymptotes, we look to the highest power. In this case, this is a quadratic divided by a quadratic. And we look at those coefficients. There's a 2, and I'm going to put a 1 right there because that's what's there. When you don't see 1, you get a 1. And what we're going to do is we're going to take these two coefficients because these have the same exponent. Now, you say, well, wait a minute, what goes on here? What goes on? First of all, let's go back. If this exponent, which is 2x squared minus 8, if that had been 2x minus 8, we would have no problem whatsoever saying, well, that exponent is smaller than this one. Y equals 0, which is, by the way, the horizontal x-axis, all right? That would be your asymptote, all right, where it tries to get to, but it never quite crosses that line. Now, the other side of it is, it didn't have 1 or 2. If they're the same, we make a ratio out of that, which is 2 over 1, and that's going to be the asymptote, which is going to be at y equals 2. So in other words, this graph, when it starts making its play, is going to get real close to 2, but it's never going to quite get there, all right? So that's our story first. So we're going to go ahead and say the horizontal, we're working over here, this is vertical. Those are vertical asymptotes. Pull it down just a little bit. And then we got the horizontal right now is hanging at y equals 2. Y equals is a horizontal, remember, x equals is vertical. Now, I said there was a little bit of a question mark here. I'm not worrying about the horizontal. It's going to work fine. It's okay. What's going on here is, are both of these going to be asymptotes? And we're going to graph it here in just a second. Hopefully we have enough time. So let's take a look at this. What we got to do is factor this puppy. So we've got x squared minus 4. And we can go ahead and factor the denominator. We've already done that, right? So we got x, what do we have? X minus 3, x plus 2. All right, now, here's time to play. Got to break this little guy up on top. Times x, let's go ahead and say x minus 2, x plus 2, because that's what x squared minus 4 will break down to. Underneath, we have this, oh my goodness, we have this x minus 3 and x plus 2, which we found a little bit earlier. What happens here is if we were reducing this fraction, you're going to see the x plus 2's disappear. However, there's still a problem because if you go back to that original function there, we have a hole in the graph, because when it hits -2, it's still going to give me a 0 down there, but it's going to also give me a 0 up here, which is absolutely meaningless. So what happens here is, at x equals 3, we have a vertical asymptote. At x equals -2, we have a hole, which means basically there's a gap running in there. So let's see. Here's what it looks like on the graph real quick. And how do you know if you have a hole or not? Hit that trace. Our trace is -2. If it gives us no value, there it is. And you see the other asymptote is at 3. Whew! And where did it lend in there? Lend at 2. Hey, thanks for tuning in this afternoon or wherever you are, and we will see you again next time.